Okay. Hello, everyone, and welcome back to yet another live coding session where we try to get a feeling for the Odin programming language and build a project that allows us to get to use the features of the language, get a feeling for it, and I don't know how it. Yeah, so to this point, we started we started sort of making a parser for the HTTP protocol, HTTP 1.1, and we got so far that we can create a connection, send an HTTP request to the server, and get a standard answer without a body. Yesterday, off stream, I continued the development, and I started to set up this client connection pool. And I think that is what we're gonna start with today. Finishing the client connection pool. And I also pulled some things out into different files to have it sort of better organized. Okay, so that works. That's good. Okay. Let's hop over to the HTTP thing. Open tmux. So let's see. Let's open, let's change the scene and get started. Odin, blah, what? Why doesn't it show the tabs? I don't know, multiple instances? No. Okay, I don't know. So let's open this http darwin.odin file. I believe we don't wanna do it this way. Probably we have to make some changes in what the platform code is and what not. At the moment, it's kind of inconsistent. That's okay. So my idea was that maybe open xColorDraw to draw something. So my idea was that we have. How can I get rid of this? I always forget how you get rid of. I get rid of this here. What was it? Navigate, flowchart. S? Is it S? No. What? How do you... How do you get rid of it? Yeah, well, if we don't find it now, it doesn't matter. Oh no, it's gone. So how do I get it back? Oh yeah. It was gone because I didn't select the pencil tool. Zen mode here, Option Z. No, that's not what I wanted. Is it Option capital Z? No. Oh my goodness, what? Toggle grid. Comment palette. Command this. Command this. Oh yeah, it's this. It's Option Z. Zen mode. Okay, so let's make this bigger. And essentially, our server will have multiple threads. And each thread, T0, T1, T2. And each thread will have a set of connections that it can manage. So there's C0, C1, C2. And this has C0, C1, C2, dot, 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 Cn. Same thing for this. Dot, oh. Dot, 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 Cn. C0, C1, C2, Cn. And every time someone goes out to our server and wants to request, wants to make a connection, so we accept on all these threads. One thread will get the connection, and it will look into this set or this pool and see whether, and get a free entry. So let's say those are occupied and this is free. So we'll look at the connections. It will see, okay, C0 is free. So assign this connection to the client connection C0. And obviously a client connection has the socket, it has all of the things in there, the parsed HTTP request, right, and so on. And when the connection is closed, this will get free again. And essentially every thread has this pool of n possible connections. And yeah, if it's full, it's not able to accept anymore, probably. We can also make a steal mechanism. We can introduce a steal mechanism. That is, if a connection wasn't used for a long time, we can steal that connection. but I guess we'll leave it like this for now. Okay, good. So what I did here was to declare all the constants. So we have some request buffer size, we have some result buffer size, we have scratch size, we have the memory per connection, and our entire memory, that is how many threads, how many connections per threads, how much memory per connection. Okay, and for now we set n threads to 6. Good. And how do I want to manage this state? So I thought about multiple things. So how do I manage the connection state? So we have either free connections or used connections. And we want to find a free connection each time an accept comes around, right? So how do we do this? The first thought I had was to manage this free connections here with a free list. That is, our pool has a free list, which is a pointer to a connection, client connection. And each time around, when we want to, so the first thing we do is we allocate a big buffer that has all of our n connections. So this is n times the size of a client connection. In our case, n is 128. And what we do is we basically, so this is not a client connection, this is more like a block. And the block only has a next pointer to the next block. And we use the size of the block to calculate the pointer to the next block. So let's say our client connection is this big. So we split our pool into these slices of the same size. So this is the size of a client connection. And when we initialize the pool, we give it the size of the client connection, and it actually basically bigger than the pointer, bigger than the size of this pointer, because now we're transmuting this as a block where we set the first thing in the struct to the next pointer. So we initialize it this way. Okay. And this is the head of the free list. This becomes the head of the free list. And every time we allocate, we just look at the head, and if the head is not nil, we return the address of this and transmute it back to the original client connection. A problem, obviously, and also if we free, we can just add to the head of the client connections. So that's pretty easy. The problem with this is that I want to initialize the client connections ahead of time. So I want to initialize at startup, init the connections at startup. Which is not possible in this case, because we're overriding basically the first part of this struct. So this gets overwritten. So we'd have to make sure that the first part of the struct is never used or never really relevant. Because so what does have to be, what should we have to initialize at startup? That would be the arena for the connection. That would be the request buffer, the response buffer, and I think that's it. So this can never be overwritten. This should not be overwritten. So I thought, yeah, maybe this is not so nice. Another way of doing it, obviously, is adding a field to the client connection that says used with a bool. But I don't like that approach as well, because then we have to scan through the entire list of our connections and see where free one is. Yeah, we'd have to iterate through this connection list. So I don't like that as well. So the next thing I thought about is splitting the connections up into two lists, two arrays, and they are both of size n. And this one corresponds to the free connections, and this to the used connections. Okay, so every time a client comes around and wants to establish a connection with the server, we look at this list here. We check the length, free array. We check its length, and if it's greater than 0, we grab the last element out of it and decrement the length. Dec length. And during initialization, we obviously fill this entire array. Yeah. And also so that we don't have to copy that much data, this is a pointer to a client connection. This only stores pointers. Maybe. I'm actually not sure if it should store pointers or not. Yeah, we will see. Pointer or not, I don't know. So because this will be quite big, right? Client connection, it's quite a big struct. Okay, but nevertheless, the idea is clear, and we decrement the length and we append this client connection to this list, to the use list. And yeah, and we refer to this client connection by its index into the array. And if we want to remove from this list, because here we're not always removing from the end, we try to swap with the last element so that we don't have to shift all of the elements down to have it continuously filled. I wonder if Odin has something like that. Array list or something. It has dynamic arrays. I know that, but dynamic arena, Odin overview, dynamic array. I just want the API of that, right? So there's an append. Probably also remove, right? Unordered remove, yeah. Pops the last element of the array, that's great. Good. Okay, I think that should work. So let's look at the function signature of append. Append element. So it has to be dynamic, right? Is there also insert? Bitfield insert. Append. I don't want to use a dynamic array. Yeah. Okay. So this is our connections. Maybe we make a new type. Let's make a connection.odin. And let's put the client connection in there. Connection, package, HTTP. Okay. And we also have a connection pool. This has a capacity, which is a U32. This has a length, which is a U32. I wonder if we can call length on this length. Length built-in procedure returns the length of V according to its type. Question is, can we? No, probably we can't use this, right? It would be kind of nice to have a dynamic array that cannot grow. You know? That to use the built-in type, but not have the allocations happening. Dynamic. Yeah. I don't know. Whatever. Okay, we have a length, a capacity, and we also have the backing array. So connections, and this is a client connection. The capacity is baked into this, so I don't need that. Just need that, right? So we have something like connection pool init. No, that's completely wrong. Connection pool init. Then we want something like connection pool append. No. Connection or something, a pool init, pool append. No. Pool acquire. You want to acquire a connection or create, acquire, pool, release. So this takes a connection pool. And we obviously need a size. But we can also just get a backing buffer, backing buffer, which is this. So pool dot length 0, pool dot connections is equal to backing buffer. Also using pool. Good. Pool acquire. This probably returns a con client connection and error pool. And this returns nothing. Just, yeah. Can we just get the pointer is the question. No, we have to provide the ID, the index, right? So this is probably not a client connection, but an index. So then something like if len pool.len is equal to 0, error is equal to true, return, and otherwise idx is equal to pool.len minus 1, pool.len minus equals 1, return, error, yeah. And pool release would be the IDX oh no, we said we have free connections, so free used, so that will not work. So we need a size and also an arena. So we have to say free is equal to make client connection size and arena, and used is the same thing. We can also just say free and used, yeah, whatever. Good. And this is the length, the free length, and use length. So if pool free length is 0, pool free length minus 1, and pool free, oh no, this is not the IDX we want to return. We want to return the IDX of the used pool. So pool.used at, so the client, so con is the free at pool free length minus 1. You can also say pool.free length minus equals 1, and we don't have to do this here. Free length is the connection. Pool used at pool dot used length is now equal to the connection. So its IDX is equal pool.used length, and we say pool.used length plus equals 1. I guess this is how we want to do it. And if we release, we have to look at the, we look at the index, pool.used at IDX, and then we say pool.free at free length using pool. Using pool. Free at free length minus 1. No. Free at free length is equal to the con. And now we have to look. So if the used length is equal to 1, also assert no. So if the used length is equal to 1, we don't really have to do anything, right? So let's see. If it's greater than 1, here we say used length minus equals 1. So if it's greater than no. It's if the IDX is equal to is not equal. Well, let's say it's less than the used length minus 1. We have to swap the 2, right? We say temp is equal to used at used length minus 1. And we say used at IDX is equal to used at used length minus 1. So this is kind of the last. So we swap it out, and then we set the used length minus equals 1. So pool it doesn't really allocate, right? If we call this pool allocate, would be kind of backwards. Hello? Okay. Okay, and what we do now in our HTTP Darwin, we want to say, okay, we want to initialize a pool. With this to do, take a look at the memory layout. We also have to set, so let's say cons, make client connection, no. We have to iterate through con in free. And here we have to set all the stuff, right? So for each con we have to, they have to be go here, delete it, go into the connection. I want to use the connection, writer buffer, parser buffer. Okay, we call this base arena base. No, base arena, right? Base arena, base arena, base arena. For all the connections in free. Temp arena, base pointer, base pointer. Let's call this con arena. Con arena, init it with a base pointer. And con arena. Okay. So for all threads, so we need something like connect con pools, and this is kind of a connection pool and threads pool. And then we say for con pool and con pools, pool init con pool with the size, which is cons per thread, and also the base arena. Base arena. Is that about right? Built expected comma, got new line. Okay. So this doesn't work. This is the free len. So free len is equal to size. Let's call this length as well. And the used len is equal to 0. Oh, here we also forgot to say free len plus equals 1. Okay, let's see. Free len is equal to size. Runtime allocator, import runtime allocator. Let's put an assert here. Assert used len greater than or equal to 1, greater than 0. Run, no, base runtime, is it right? Net TCP socket is not a type. import core net. Also mem not available, import core mem. Okay. Con arena. This has to be base arena. Undeclared name used length. Right. Temp arena. This is the con arena. You mean con pool? Yes. Look at this compile time. So if I do something like rmhep, rf, hp.dsym, and time, Odin build, do this again, rmhep, rmrf, hp.dsym, and then does it have anything else here? LSLA? No. And Odin build. Time. Okay, I don't know why it sometimes takes so much time. Okay. So it initializes a connection pool. So let's use that connection pool. We don't need this anymore. We don't need this. So let's just say for, and we want to, where's the accept? Oh, it's here. Clients. So that will be here. Obviously, this has to go into the threads to do. This code has to go to the threads. Okay. So now this, right? To do, probably we want the initial read to go here as well. The read to go here as well. The read from the socket. One second. Okay, so I don't know if this works. Oh yeah. So here we want to say, let's say our con pool is equal to con pools 0, and just say pool acquire so that would be an index into the used, right? So IDX con available pool acquire pool con pool, if not con available return no connections available, no free connection slots available. Okay. And then we would sort of say con client con let's say pool con from IDX, and then pool con pool. Oh, we might just say, okay, con pool dot used at IDX. This is a pointer to a client, no. Pointer to client connection. I have no idea if this works. curl-v localhost 8080. No free connection slots available. That is weird. Let's break at 42, LLDB HTTP, break HTTP Darwin 42, run. Okay. Change this. It's okay. Continue here. Run. Good. Next, print the con pool. Freelan is 128. Oh my goodness. What is happening? So do this again. Run. Good. curl, print the client. IDX. IDX is 0, which is not right. Connection, pull init. Pull init should set the free length to the length, which is 128. IDX is use length. Huh. Why is error? IDX should be use length, that's right. And print con available. Oh. This is the error, right? Error, pull error. I don't know. If pull error, good. Didn't send a response, right? That's kind of unfortunate. Say LLDB. Oh yeah. So we have to say client con dot also pull acquire should give us, should provide this client, right? Pull acquire a TCP socket. Client socket. TCP net.tcp socket. So we said used set con dot client socket equal to client socket. Oh my goodness. Okay. Break loop. Client con must be an identifier. What? $57. Okay, HTTP. M to reply from server. Sec faults. Great. Okay. So something does not work here. I'm right back in a second. I have to go get some water. Okay. Okay, so we got a segmentation fault. Let's see why that is. Let's just break it 56. HTTP Darwin Odin 56. Run. Curl. Okay, print the client can. This has an address. And it is initialized. Does it also have a client socket? Yes, it has. Seems to be correct. So let's step into this. Bytes read. Okay. HTTP parse worked. No, it didn't work. Entry is null. Connection arena. Okay, so why did it refuse to allocate? Print. What do I have in here? Connection dot request dot header. Header map. Head is null. Should be null. Okay, so let's try to rerun this and go here, step into this, step into HTTP parse. Oh, you know what? I guess this is because in our connection, this arena is only stack allocated, and we set that to this, right? And goes out of scope, and we're screwed. So what we actually want to do is something else. We want to, yeah, but then we need two arenas, right? We have a base arena and a con arena. Is that reasonable? I don't know. So arena is equal to con arena. And then in our pool init, we say, okay, we have also for each pool an pool arenas, con arenas. This is n threads arena. We said arena init con arenas. Let's also get an index. Con pools at IDX and con arena con arena at IDX. Here we say make. Now arena init. No, we just have to give it the con arena, right? We can handle this. So this is a mem.arena. And then here we say, okay, we say arena init. This is a reference to it. And the con arena with make u8 con scratch size base arena. And then we set this to arena mem.arena allocator con arena. Right? Does that work? Con pool. Con pool. Con arena. Arena init. Yes, this is mem.arena init, which is also nothing we should do here. We do it here, mem.arena init. Con arena IDX. Con arena. Con arenas. Con arena. And we'll type this is a mem.arena and HTTP. Okay, so now it works. Nice. Also, what we should now be able to do is do this again. Yeah, this is something that wasn't possible before. Yeah. That's great. So our connection pool somehow works. I don't know if it completely works. Obviously, when this thing closes, we also have to say pool release. Now let's make the pool a little bit smaller. Let's make it like 5 or let's make it 4, because at the moment, at some point we should go out of no. Why can we acquire so many things? I think because we have to 1, 2, 3, 4. Yeah, so now it fails because we run out of connections. Because we did not we did not release it. Pool release and then con pool with the connection IDX. Let's call this connection IDX. So let's see if this works. Connection So now we should be at 1, 2, 3, 4, 5. Yeah, so now we can go on indefinitely, right? Let's look at connection again and see if if the release procedure is correct. So so the connection, this is the use, this is the IDX, right? At freelan is this. If the index is less than the useLang minus 1, so if it's not the last element, we get the last element and swap it into this, and we decrement. Yeah, I guess that's fair. Good. So connection pool sort of works. Let's say git status, git add all git status, git commit, added connection, add a connection pool with free and used array, git log one line. Okay. At some point I will commit this to the GitHub as well, but at the moment I don't have the SSH key on my system. Ugh. Okay, that's great progress, I guess. Is there something else? I guess what we forgot to do is when this goes out of scope, when a connection goes out of scope, we also have to reset the connection. This can also be a bug. Connection reset. Let's go into connection and make a connection reset. And this is a con client connection using con. And yeah, the client socket, we don't really care with that. So maybe client socket, we should set that to 0. Oh no. We should be calling free all, I guess. Free all. And free all. Let's get an allocator. So free all con dot arena. Then parser dot offset 0, parser dot previous offset 0, response dot buffer, no, response dot offset, no, is writer dot offset is equal to 0. Does the request have something? Oh yeah, also request dot header map dot head nil, request no response dot header map dot head is equal to nil. Okay. I mean, free all, this should just reset the base pointer, right? If we somehow break at connection that Odin 24, run, connect, so print count at arena, next print count at arena, still the same thing. I wonder, this is data. Arena allocator proc. What does it do? Let's continue. Step. Allocator procedure. Free all. Step. Arena free all. Step. And just sets the offset to 0. Okay, that's good. So this just sets the offset of the underlying arena to 0. Good. And the index into this array should be the thing that we store in the data for the ePOL or KQ. Okay, let's actually try to set up KQ. Is that something we should do? For asynchronous stuff. So what KQ does is it has some file descriptors. It has a set of file descriptors. FD0, FD1, FD2. And it looks at all of these and sees if they changed. And we call something, some method, I think an ePOL, what was it in ePOL again? ePOL. ePOL weight. Yeah. In KQ, it's probably something else or something similar. K event is a new kernel event queue and it returns a descriptor. Yeah, it's basically an event queue that waits for some of these to get ready. So we can have multiple connections at a time and see, yeah, and only look at those that are ready to poll or ready for reading. I have never done this on BSD or macOS. So I'm not familiar with the interface, and I don't even know if Odin supports this in some way. KQ, yes, it does. That's good. Courses KQ. This was generated for target Darwin ARM64. Okay, that's good. Because we don't have an Intel Mac. Usually I want to look at an example, but I think we don't have one. So we have, basically we have two functions, KQ and KEvent, and KQ will be the function to set up the queue, and KEvent, so that's what they did here as well. Yeah, KEvent will poll these. There was something on like poll on Linux. Poll is similar, but I guess it does less. Poll versus epoll. Yeah, okay. I'm not too sure what the difference really is. So whatever. This gets a POSIX file descriptor. Oh my goodness. Please. The POSIX file descriptor is in our class. Why is it doing right click when I left click? Sometimes the mouse is somehow buggy. I don't know why, though. It still does it. So somehow, if I don't have my keyboard connected, but connected to the different computer, it's interpreting the clicks in a different way, which is weird. Okay, so whatever. What we want to do, or what we can also do, is do multiple threads first. But I don't. Yeah, maybe not do that. Maybe we just do a single thread for now, all in the main loop, and see how it goes. So I guess we just call KQ, and we also have to import courses. This obviously is now platform specific. Where is it? Here, courses KQ. Courses KQ. Good. Okay, then we want to call KQ. KQ.KQ. This gets a file. POSIX FD. Oh, they changed that. You cannot click on those anymore. Okay. No, it's what? KQ should create the file descriptor. KQ is a void. Why do they expose it like this? Let's see. Oh no, that's the return value. Okay, I misread that. Yeah, that's the return value. Okay. No, this just calls KQ, and this returns a file POSIX file descriptor. So KQFD. And an erno. So erno, I'm not sure. Erno. Get erno. Is there POSIX.erno? Okay. So if erno is not equal to POSIX.erno.none. Is that right? So import POSIX. Is it core POSIX? No, it's probably basic POSIX, right? What is it? Core sys POSIX. Core sys POSIX, okay. Maybe it can infer this. If it's not equal to none, I cannot, so proper, also to do a proper error handling here as well as in the GP parser. So cannot cannot create kernel Q. Create R. There's probably also an ePrintLn if that is available. Oh, it's sys POSIX like this. And none. Okay. So we have the kernel QFD. The next thing, how do we add things to this DV set? No, it's K event, right? So the K event system calls used to register events with a queue and return any pending events to the user. The change list argument is a pointer to an array of K event structures. All changes contained in the change list are applied before any pending events are read from the queue. The end changes argument gives the size of the K event structure. The end event argument determines the size of event list. When n events is 0, K event will return immediately, even if there's a timeout specified, unlike select. If timeout is a non-null pointer, it specifies a maximum interval to wait for an event, which will be interpreted as a struct times back, blah, blah, blah. Okay. So we have to create a K event. Where was it again? So this is KQ. No, that's not in here. KQ K event. Okay, K event gets the file descriptor, the change list, the event list, and a timeout. Libc times back. Okay. Let's read it again. So change list, event list, returns an int. What is that return value? It's a little bit different than the ePol API. So what's the return value? K event the event list argument is a pointer to an array of K event structures. The n events argument determines the size of the event list when n events is 0, blah, blah, blah. To factor poll, the timeout argument should be non-null. So does it return how many events it put in there? Return values. The number of events placed in the event list. Okay, I see. So I don't know how many we need, but let's have a change list. KQ change list and KQ event list. I don't know how big this should be. So that's a KQ.K event. Is that the name? Weird that they named it like this. K event, not K event, kernel event or something like that. Weird. This is also a KQ.K event. I don't know what the size is. Maybe let's make them both 16. K event list size. Event list length. I don't know. This should probably be the size of the connections, at least for the changes. Okay. So first and foremost, we have to add to this so let's look at the K event structure. change list. I wonder. So this is and changes, right? Yeah, whatever. Okay, event list length. Okay. So first and foremost, we need the k event. This is like the server event. Or like KQ change list. Yeah, or like do it like this, KQ change list. At 0 is equal to server event. Yeah. So server event is that, let's see. Let's look at the structure. An identifier, value used to identify this event by the attached filter. There is a filter that is, okay. Is there a filter here as well? Yes. That's probably just an enum. Filter, backing, filter. Value used to identify this event. Oh no, that's not, okay. User data passed through cron, full specific data. Okay. So K event has an identifier. This is the socket. And let's see if there is a file descriptor, TCP socket. Maybe we have to change everything now. TCP socket. None other tunnel type. Okay, this is just an I64. Can we transmute this to an I64 back? I64. Because this K event this is a uint pointer. Okay, I don't know if that works. A filter. So filter kq.filter, and it's read. Enum filter backing. What does that mean? Filter backing. Let's say this is just a dot read. Also takes flags. This is a bit set. How do you do bit set? Again, how do you do a bit set? started, overview, bit set. Okay, bit set. Bit sets. Element type can either be an enumeration or range. Okay. So this is just an add. Dot add. Implies enable. Disable event after reporting. Clear event state after reporting. And the file detected. I don't know if we need those. Error maybe. Data contains error now. So probably this is what we want to set. So dot error. Okay, this is the flags. F flags. Filter specific flags. Okay. Raw union. Read write timer. Okay. I don't. How do you do this again? How do you do unions again? I always forget. Union and bool. Oh no, this is a raw union. Raw union. Okay, I don't. RW flag. Low watermark. What? RW flag. Proc flag, vnode flag, timer flag. Okay, I don't know what all these are. We just set it to 0, I guess. Does that work? Why did my Safari die now? Okay, it's not dead. Data. Zero. And a raw pointer. Let's also say this is 0. Or -1. Your end pointer. K event. KQ.K event. Oh, it's a raw pointer. Raw Why can you have a as type raw pointer? Why? It must be converted to uint pointer first. Cannot cast -1 as uint pointer from untimed. But that works. So this would mean that now we can do kq.k event, and we pass in the kqfd. Let's also call this kqfd. We pass in the kq change list, but only and changes is equal to the 1 changes and also the KQ event list. And this is the n events. Or event count. Let's call this change count. And in here, we now have to say if event count is greater than 0. Now we go through the events. So for event idx and 0 dot dot event count. The k event is equal to kq event list event idx. And now we want to look at the identifier k event dot ident. We just pass a null here. You don't know, or nil. Okay. So if the k event is equal to this uint pointer socket, then we do something, and else we do something else. So then we accept. We try to acquire a connection. We now try to acquire a connection. 1 second. And now we have to add this to the change list. So what was the KQ event change list? So we need another K event. Also, this is probably wrong with the read. So this is kind of the new event. KQ change list at change count is equal to new event and change count plus equals 1. Also, we have to check if the change count is greater than or equal to the length of the KQ change list, then we have to do something. No changes left in the event, in the change list. No slots left in the change list for the KQ. So this is bad. To do handle this properly. This of course is very sloppy. And that's probably, this is very sloppy. Is that right? Sloppy with 1 P? Sloppy? I don't know. We want to read, we want to add, we want to get an error. But now we want to convert this to uint pointer and the con IDX. We want to provide this as data. Okay, and else. Else we get this here. Probably not exactly. So the con IDX is now equal to the K event dot identifier. I don't know if we can just cast this. This is the client connection. And now we want to handle the connection. And if it's closed, we release it. And we also have to K event. We obviously have to remove this. This was not the socket. Also, this is not the socket, this is the client. And this is the client. Now this is K event kEvent.ident. This is a read, and this is now flag delete. So this is delete. Do we need a filter on this? I don't know. Okay, just delete this. Also report an error. No data. Yeah, probably we don't need this here as well. No. And let's just assert change count is less than kq less than or equal less than kq change list, and we set kq change list at change count equal to new event, and change count plus equals 1. Make sure this works. Let's see if this builds. So event count. This can it return? What does it return? It returns also an error. Okay. Erno. KQ Erno. If KQ Erno is not equal to .none, assert false, or so not whatever, I don't know. fmd.e println error while polling on KQ. This should not happen. Oh, it also needs a timeout. I'm not sure what the timeout is. Search for timeouts. When an event is 0, blah, blah, blah. If timeout is none, null pointer. Okay, we just make it nil. Where is it? kEvent nil. Break loop. We don't have to break the loop. Oops. Odin. KQ event list. Changes. Change count. This is in 109. No, it's not the identifier, it's the data. No, it's not the data, it's where is it? It is kEvent. Where is it? kEvent. It's the user data. It's the user data. Countercast from must be converted to UN pointer first. Hey, it works. No, it doesn't. Pool acquire. Also here, we should check this error, if error. Error while accepting. So that's a trap. Runtime assertion, use length is greater than 0. Oh no. Why doesn't it acquire? Okay, I don't know what really happened here. We'd have to look at this. Git status, but I have to go offline now. Git add. Git add dot git commit. Edit KQ event polling. Left a bug where used length is less than or equal to 0. Probably because KQ sends an event sends another event after we close the connection. Okay. This is it for today. Leave a like and subscribe if you want. We'll see you. See you